and I added a chemical known as glycerol because I wanted a substance that could be very strong, but was very light. These bubbles are great bubbles, but they're heavy bubbles, right? And so they fell. I wanted a bubble that was very light that could actually float. Chemists are always very proud of their products because you go ahead and you design something and you build something that actually is awesome. And bubble juice is awesome. Have any of you made bubble juice at home? You just got your detergent and your water, you made your ghetto bubbles? Did they work really well? No, they suck. Yeah. And so the special ingredient is glycerol. It's almost like a fat substance, I think. Lots of C's, lots of H's. It's literally C-H-O-H, C-H-O-H, C-H-H-O-H. The chemical formula. Do you know what a C is? Carbon. Do you know what H is? Do you know what this is together? Carbon, hydrogen. Carbohydrate, hydrogen. This is a gas known as methane. This is a fart. If you go ahead and take cow patties and you put them into a box, you can actually collect a whole bunch of it. Methane is a very productive gas in our environment. They blame it for global warming. And I don't know if you've heard I just was reading it today. I guess over in Russia there's like this huge hole that just came out of nowhere. And now they're saying it has to do with the gases in the ground and the breaking down of the ground and everything falling into the hole. I don't know. But when it comes down to chemistry, you need to know what you're putting together for an objective. You have to have a reason for using methane. Do you know what we use methane for in our houses? What? What? Heat? Do any of you have a hot water tank? It's heated up. We use the gases to heat your water, right? Here in the building, we've got it running through all of these pipes. And that's another safety issue. Do you see them at your lab stations? My gas is on. Is your gas on? No. I hope not. My check still working. You check? Oh God. Did you just turn it on? No. Oh gosh, is it off? No, those are already off. I turned them all off. And so, if I want to do an experiment where I want my bubbles to float, I have to make my bubble juice, and then I have to put a gas inside of my bubbles to also help it float. Do you know why this gas allows and helps these bubbles to float? There's a special word. It's a D word. Density. This is not a dense gas. Can you think of another gas that's not very dense that makes things float? Like your helium, right? And so you look at properties, you look at the characteristics of your elements to go ahead and combine to get a product. Here's a great example. These are panels that are fire retardant. Some chemist went ahead and made a material that can't catch fire unless it's extremely, extremely high temperatures, right? And so what I want to do is I want to test to see if that's true, if I can catch these on fire. So if I'm being safe, I'm going to go ahead and make sure I light this from a distance. I'm so proud of you. I'm so proud of my bubbles. These are so beautiful. Wait, no. I'm going too slow for my bubbles. So these things shouldn't light on fire. If they do you know where to go? I haven't told you yet, have I? I haven't taken us out there. We'll just get out of the room if it catches on fire, okay? Okay. That's pretty awesome. Okay, I'm going to try it from the top now. This thing is all gross. Those are some Awesome bubbles. Oh God, what do I do? What do I do? What do I? What do I do? What do I do? What do I do? So a lot of times what happens is that people totally freak out. If something's going not in the way you're not planning, just turn everything off and be calm. I don't know. Have any of you been around a grease fire before?
Yeah, I just put fire on it.
Oh my goodness. Don't pull water on it. You want to see that again?
Yes.
Can you feel the heat?
Yes.
Yeah.
And again, as a chemist, you really have to take time in your experiments to make sure that they work. This is not, you should see Mr. Weiss do this. I don't want to make fun of Mr. Weiss. Those? Can anyone tell me what's happening to the gas inside of these bubbles when we combust it? When I combust? No? How about the bubble juice? What happens to the bubble juice? It just disappears. The bubble juice actually comes right on down. You might, hold on. The bubble juice actually just falls right back down. I have to be very careful. I'm cleaning all the time. And then what happens to the gas when it combusts is that all the C's and the H's, they just boom, they just bust off each other. And that's why you get heat. Heat is just movement, right? Ooh, do you see it drip? It's dripping. It's good bubble juice. Wonder, what do you think will happen if I light these bubbles up here? Oh, wait. Did you see it going? I'll do it one more time. And then we'll pretend like we set the class on fire and we'll go outside. Does anyone know what time we get out of here?
11:19.
Did you see that pop? All right. I've just set the class on fire. You're going to go down the hallway, down the stairs to the front of the building, gather all your stuff.